I am Dr. Shweta Shukla from Applied Science Department of KIET Group of Institution. Today I am going to cover the topic concept of nanomaterial and its application. In this topic I am going to cover the following contents: introduction, what is nanoparticle, nanomaterial dimensions, methods for its preparation, properties of nanomaterial and its applications. Nanoscience in nature. I want to say that the first nanoscientist of Earth is nature. It created number of masterpieces which guided us today. For example, butterfly and peacock wings, lotus leaf, which is a most waterproof surface because of its hydrophobicity. And I want to say one more thing, the bhasmas which we are using as a medicine in Ayurveda are the best example of nanomaterial. So we can say nanomaterial or nanoscience is not new in this era. Norio Tonguchi uses the term nanotechnology first time in 1974. Now the question arises, what are these nanoparticles? Nanoparticle is any material having at least one of its dimension in the range of 1 to 100 nanometer. It may be in another dimensions also, but the necessary condition is in one dimension it should be 1 to 100 nanometer. The word nano derived from nanos. It means dwarf, that is small. So we can say a nanometer is 1 billionth of a meter. There are two terms which we are using frequently in nanomaterials. The first one is the nanoscience and another one is the nanotechnology. Nanoscience is the study of phenomena and manipulation of these atoms, molecules whose size are in nanometer range. While the nanotechnology, it is a technology of design, synthesis, characterization and application of these material on nanoscale. Now the question arises, how can we understand how small is nano? We cannot see the nano with the naked eyes. If we compare a human hair, which we can see, it is approximately equal to the 80,000 nanometer. The bacteria size is equal to the 2000 nanometer, while a sheet of paper is about 1 lakh nanometer thick. A strand of human DNA is 2.5 nanometer in diameter. So we can see that how small nano is. I want to show you a simple example. If we compare, the population of India is 100 crore and each Indian, you or me, is nano in comparison with the total population of India. So by this example, we can understand how small nano is. Now, types of nanomaterial. Nanomaterial are divided into three categories, that is 1 dimension, 2 dimension and 3 dimension. 1 dimension which has only one parameter. It may be length, breadth or height. For example, the coatings, thin layer coatings, surface coatings. These are the example of 1D nanoscale. 2 dimensions, it has only length and breadth. For example, nanotubes, nanowires. That is 2D at nanoscale. 3 dimension. It has all the parameter, that is length, breadth and height. For example, quantum dots, and these are the nanoparticles. Now the question arises, why small is good? Surface area to volume ratio increases, hence reactivity increases. This makes today's products lighter, stronger, faster, smaller, and due to its smaller nature, it can get into small spaces, different properties at very small scale, more energy efficient and more durable. Now, the methods for the preparation of nanomaterial. Nanomaterial can be prepared via two approaches. The first one is the top down and the second one is the bottom up approach. We can see from the figure, in top down approach we are starting from the bulk, and while in bottom up approach we are starting from the atoms. Top down approach. In this approach we begin with a pattern generated on a larger scale, then reduced to nano scale. In this method, small features are created on large substrate by repeated pattern. This approach is expensive, slow and not suitable for large production. For example, ball milling. Ball milling is a type of grinder used to grind the metal into extremely fine powder. Mechanical grinding, lithography, etc. are the examples of top-down approach. The another one is the bottom-up approach, in which we start with a very small unit of an individual molecule or atom and assembles these building block unit into larger structure. This approach is less expensive and suitable for large production. For example, molecular self-assembly. It is an automatic management. Chemical vapor deposition. Properties of nanomaterial. Nanoparticles are unique. We know it very well. This is because of its physical behavior of particle changes from classical physics to quantum physics with decreases particle sizes. Size effect. Only by varying the particle size of the material, properties like melting point, solubility, color, transparency, catalytic behavior changes. As in case of gold nanoparticles, there is change in color by varying its size. Composition effect. Different physical and chemical behavior of the material is observed by varying the particle compositions. Surface effect. Properties like conductivity, catalytic behavior, optical properties alter with the different surface properties of the nanoparticle. Applications of nanotechnology are wider. In aerospace industry, in nanoparticle in coatings, that surface coating, in paints, in primers, in food sciences, in medicine for drug delivery as a catalyst, in sports, vehicle manufacturing, energy applications, in textile, that is suprahydrophobic cloths, CNTs in a space elevator to make it lighter, in cosmetics, in information technology, in defense and security, in biotechnology, in manufacturing of sensors, in robotics, etc. Thank you.